we had these notes for section 8.6, but we're also going to use these same exact notes for 8.7. So these are notes for 8.7. And the only difference between 8.6 and 8.7 is that we're going to have a values that are not equal to 1. Okay, we're going to have a values that are not equal to 1. So in the previous section, we were able to use a shortcut. And what was the shortcut? You could only use it when a did equal 1. So for example, let's say I had the quadratic trinomial x squared minus 1x minus 20. Okay? And right there, the a value is equal to 1, so we're able to use a shortcut. Now, what do I mean by the shortcut? You could jump right into your answer format. Put the parentheses there, put the x right there, and the x right there. Why are we able to do this? Because x times x is x squared. Now, we could clearly see that if the a value was something like if it were 12, then it wouldn't be x times x gives us 12x squared. It might be like a 3 right here and a 4 over here, or it might be like a 6 right here and a 2 right there with the x. So it gets really complicated if your a value is 12 or if your a value is anything other than 1. So we're able to use a shortcut when the a value is 1. Let's just finish this one off. What times what is negative 20 that if I combine together is negative 1? If you don't see it, make a list. Negative 1 times 20 is negative 20, right? How about negative 2 times 10? Negative 3, no, negative 4 times 5. Those are all the possible ways of getting negative 20. And if we combine them to see which pair of numbers combines to give us the b value, negative 1, this guy, if I combine it, gives me 19. This gives me 8. This gives me positive 1. So I know I want a negative 1, and this gives me positive 1. That means these are the right numbers. They just have the wrong signs. I want it to give me a negative 1, so I need to change both signs. Positive 4, negative 5. So that's going to be a positive 4 and a negative 5. That's what we used to do last week, and we're still going to continue doing that using the shortcut. But today we're going to jump into factoring quadratic trinomials that actually have a number right here. And we will not be able to use this shortcut. We're going to have to go back and do that long 4-step process, which is actually kind of like a 6-step process. Check it out. Let's say we have the quadratic trinomial 2x squared plus 5x plus 2. Right here you could clearly see that the a value is not 1. The a value is actually 2. So you cannot use the shortcut. So we actually have to go back and use this long 4-step process, which is really like a 6-step because you got to do factoring by grouping for your final step, which is several step process itself. So let's go through this. Let me move this to the side. Let me move this up. Let's go through this. Step 1, it says a times c. So let's actually do step 1. What is a times c in this case? A times c is? Okay, a is just the number in front, the leading coefficient. C is the constant. Forget about the x's. What is a times c? 4. Okay, so that's your answer to step 1. Moving on to step 2. Now, what is step 2? Step 2 says, Step 2 says, think of the multiples of that number that combine to give you the middle value b. You may have to make a list. Okay, let's make a list. So again, we're thinking of the multiples of this answer from step 1. So how could we get 4? Well, it's either going to be 1 times 4 or 2 times 2. And that's it. 3 times something doesn't work. 4 times 1 we already did. Those are the only 2 pair of numbers that give us the answer 4. Okay? Now, which of these pair of numbers gives us the middle value 5? The 1 and 4. So this is our answer for step 2. This is what we're going to use from here on out. Okay? So the answer for step 2 is the pair of numbers 1 and 4. Now, step 3 is where it gets really weird. Let's check out step 3 on our notes. Step 3 says, get that pair of numbers from step 2. Okay, so we're going to take the 1 and the 4, and we're going to rewrite the b value as those 2 numbers, thus changing your trinomial, 3 terms, to a polynomial, 4 terms. So you're probably thinking, why would I want to make it bigger? I mean, right here we have 1, 2, 3 terms, and what step 3 is telling us to do is to take this pair of numbers and rewrite the b value as 2 separate terms. So instead of 5x, I'm going to have a 1x plus 4x, because 1x plus 4x is really 5x. So let me rewrite the whole thing. This is step 3 right here. Step 3 is rewriting the whole thing, but changing your b value to become those 2 new terms that you got from step 2. So we have 2x squared, and instead of the plus 5x, I'm going to write it as positive 1x plus 4x, because 1x plus 4x is really 5x anyway. And of course the last term is the plus 2 at the very end. So why would we want to change three terms? Why would we want to change 3 terms to 4 terms? Because now we could actually do the final step, step 4, which is factoring by grouping, and which is a 3-step process itself. So how do we do factoring by grouping? First we want to separate the 2 groups. So I'm separating into 2 groups. Step 2 in factoring by grouping is to factor out the GCF from each group. So in the first group, what could I pull out? What's in common in both terms in the first group? Is there a coefficient of 2 in both? Just an x. So let's pull out an x. I want to put an x out here. And if I pull out an x, what's going to be left on the inside? 2x plus 1. That's it. Okay, now let's look at the second group. In the second group, what's in common in both that I could pull out? Pull out what? A 2. Bless you. So if we pull out a 2, what's going to be left on the inside? 2x plus 1. Now this is a very good thing because we have the same exact binomial in the first group and the second group. And the next step in factoring by grouping is to take a step back and pull out what's in common in your first group and your second group, which we said is this binomial 2x plus 1. So I'm going to take the 2x plus 1 and pull out the 2x plus 1's, the binomial out here in front. So I'm going to take this binomial and pull it out, put it in front. So here we go. Let me make some more space. So I'm going to pull out the binomial 2x plus 1 out here to the front. So if I do take this and pull it out, what's left right here? Just an x. And what's left over here, if this is gone, the 2 is the only thing that comes down, the plus 2. And ladies and gentlemen, that's factored. So your final factored form answer to this is 2x plus 1 times x plus 2. And that's it. So to sum it up, this original quadratic trinomial that had an a value out here is really factored as these 2 binomials. Okay? How could you double check it? Well, you could always distribute 2x times x, that'll give you 2x squared. 2x times 2, that'll give you 4x. 1 times x, that's another x. When you combine the 4x and the 1x, you get the 5x that's in the middle. And 1 times 2 is 2. So if you did distribute and combine like terms, it would take you back to the original quadratic trinomial that doesn't have an a value of 1. So again, why would we want to factor? Because ultimately when we're solving equations, like if this were an equation equal to 0, then you would have an equal to 0 down here, which would mean that you'd simply use the zero product property to split them and find your final answers. You would say 2x plus 1 equals 0, and then solve it, you'd get the answer negative half. X plus 2 equals 0, you'd solve it, you get x equals negative 2. Anyways, let's jump to the worksheet, which is our homework.